Hey, Rick's Barber here. I'd like to show you a machine that was a collaboration between John Harriman and myself. This machine is rather unique. I'll have to give you some background. My wife Donna is a figure skater. She's very serious about it. She's got coaches and she competes nationally. And one of the big hassles is trying to find people that know how to sharpen figure skates. So here's the figure skate. Obviously the boot's been removed. This one happens to be at its end of life, so she won't be upset with me grinding it without her being here. When I do sharpen her skates, Donna is here with me, and she's quality control. And she also watches the process to make sure I do everything right, because there's a lot of steps. So what I have here is a special grinding wheel. It's very fine, and it's run by a motor that's controlled by a VFD. The motor is sped at the maximum RPM allowed for this stone. So if I were to take this wheel out, it would have an RPM on it, and that's what I dial in here. Down at the bottom here, this disc is actually fixed, but it's a follower. And I'll show you in a minute the carrier that the blade goes on that touches this follower. And these figure skates, these happen to be SP Terry, no, they're John Williams, pattern 99s. They have 3 different radii making up this, what looks like a single arch. It's actually 3 of them. And the first challenge was to reverse engineer them, to figure out what were those radii and where was the center of each of those radiuses, so that I could write a CNC program and cut the pattern. Now the pattern was cut by the late Dan, I'm blanking on his name, it's terrible. Dan Benoit. I'll show you that pattern in a minute. But that pattern is the master. And every time I sharpen the skate, I return to that contour. And that's extremely important, because what it means is, as long as I'm sharpening these often enough, which I think is about every 18 hours of ice time, there's no perceptible difference. You don't have to get used to the new grind. And when these are freehand ground, it's a crapshoot. So anyway, first step here is we have to dress this stone. It has a special radius going this way. This happens to be a 3/8 inch radius. I have here a wheel. It's coated with diamonds. And I press this up against this wheel and I can dress it. And there's actually a lot of applied geometry here. This wheel is spinning in a fixed orientation. It's not perfect, but it's fixed. And I'll get into how it's fixed, part of what John contributed. When I run this dressing wheel over that stone, it precisely sets the height of that radius. I don't know what it is, I don't care, but it's consistent. And then when I sharpen the blade, it's going to be at exactly the same height, so I get consistent results. So there was an initial adjustment of the carrier and the dresser that was done about, I don't know, 5 or 6 years ago, and that's it. So what I'm going to do is start by dressing the stone. and I simply feed in until I get pink all the way across the face of the stone. The next step is, here's my carrier. It's massive because I can't tolerate any flexure at all. Each pass I've calculated I'm taking about 75 millionths of an inch, so any flexure is going to throw this off. Now, buried in here is my pattern, and I oil that and I run it up against the follower here, which you can see here, this slides in and out. So I move it all the way out, and then I'm going to move the carrier in very carefully until it contacts the follower, and then I can lock it. So first thing I do is I glue the edge, because it's very important to know where I'm taking off metal, because I don't want to take off too much. These blades run about $400 a pair, and if I were to hog off too much metal, I've ruined them. So it's blued, and I have here, I don't know if you can see it, but right here is a cylinder. There's another cylinder back here, and then there's a post here, 3 points of contact, and that defines the blade. And I put it on all those three, and then I have these clamps which come down. And I clamp those down, and here's some of the trickery. The ideal way for this to work is that the carrier moves in and out and side to side, X and Y. Well, that's complicated, and I didn't want this to be complicated. So looking at how much I have to move it in and out, and some of the geometry that I had here, I discovered that I could get a very good approximation to that by pivoting. So instead of having an XY plane, this moves in and out. And that way, I'm sliding it along this rod, and that's good enough. It's very good. In fact, it's a few tenths of a thou off of if it was XY motion. And the proof is in the pudding. We just put on the third set of blades in about 6 years. So she's been skating on those for 6 years. The machine has been very consistent. So it's good enough. Now, what I do is I move this carriage in, and you can probably hear the run out of the wheel. It's not much, but I use that as an indicator to how deep I need to be. So I lock the follower, and then as I move in and out, oh, and the other thing I do, which is very important, is I can't grind the pick. It's this sharp spike in the front. So I have this block I put on, and then when I'm moving back and forth, it prevents me from hitting the pick in the front. So that's the basic setup. Let me take you on a little tour of how the motor is mounted, because it's very clever. John had me set up 3 pads. These posts, these threaded legs here, are locked in place. They're part of the calibration. There you go. And this pad, when these are oil hardened, This pad here is a V. Now, let me spin you around here. Oops, guess not. This one, let's see, kind of hard to see. This one here is flat, and the one in the back is a countersunk hole. And by doing that, I can take this motor off for storage, and when I put it back on, I just tighten these bolts. All these bolts do is pull straight down, but all the alignment is in the flat, the countersunk, and the V. So it always goes on the same way. And that keeps the motor consistent. Because I can't leave this set up, I gotta break it down. So, put you back up here. Now, demonstrating how this thing works is a little tricky because the manufacturer changed the reference plate. The back height was moved about 75 thousandths of an inch. So I had to adjust my pin reference. So when I go in here now and try to sharpen these blades, it's not going to be very pretty because it's out of alignment. So I don't think I'm going to sharpen it today, but the way I would do it is I come over here and I push real fast because you don't want to let it sit. And when it sparks out, I'm taking off maybe 50 millionths of an inch. So I get a nice consistent grind all the way through. And then after Donna has skated on them for about 18 to 22 hours, we come back, and it's surprising how the wear pattern is a function of what she's been practicing. So sometimes the tail, the back end here, is worn off, and sometimes the near the pick is worn off. It just depends. So then when we're done grinding it, and she's the one that determines when it's sharp enough. She runs her finger across the burr and she can tell. Then I have this stainless steel plate, and the skate goes on that. And then I have this little guy. The angle there matches the bevel on the blade. The flanks of this blade are beveled because this is not like a hockey skate. You have a hollow, and then on the sides you've got a bevel, and it's that interface that's ground. So when we run this piece of emery cloth on here, all we're doing is taking the burr off of that bevel. Now, once you've lost all the bevel, then the blade is done, it's spent, and that's what I have here. So, hopefully that'll give you a sense of this unique machine. The idea of having basically a surface plate came from a master skate grinder in Chicago named Story, and he ground skates for people in the Olympics, and my wife used to take her skates there when we lived in Chicago, and it was really interesting because he just had the touch. So he had a grinding wheel like this, he had an adjustable carrier, but he could do it by eye and by looking at the spark pattern and ear, and he was just as good as this machine. I should say the other way around. This machine was just as good as his. But it's just too much trouble to send these things from Phoenix to Chicago every time we need them ground. So anyway, that's what I got for you today, and I hope you enjoyed it. Thank you.